All right, so this is the day 24 worksheet. This is a PDF of my answer key. I posted the PDF up online, but I thought I'd talk through a couple of these problems here. I might talk through all four of them that you had to do just so you have that to refer to. So if you want to fast forward and only look at the ones you need, that's definitely an option there. You don't even really need to watch this if you felt like you did a good job on the homework yourself. So 1 and 2 I already went through on the notes video. So I'm going to start by looking at number 3. So I worked with the left-hand side. So I just rewrote my left-hand side here. Really, I liked this side better to start with just because it had some operations that I could do. On the left-hand side, I saw that it was sine plus cosine squared. So I thought, let's multiply that out. So that's the first thing I did here. So sine squared plus 2 times sine times cosine plus the cosine squared. I just left the tangent on its own right there for right now at least. And then I noticed I had a sine squared and a plus cosine squared. They weren't next to each other, but sine squared plus cosine squared is 1. So I said, okay, that equals 1 plus 2 times sine times cosine. And then again, still times tangent. So then I kind of start to look at my other side here just to kind of decide what I'm going to need to do. There's no parentheses in this last side here, or on the right hand side here. So I thought, okay, let's get rid of the parentheses and now let's distribute the tangent through. So tangent times 1 and then tangent times this whole thing here. So that's what led me to this line here after I distributed. So now I kind of looked at it and I said, okay, well, I have a plus, and notice I have a tangent. So that's good. So I have a tangent plus. That must mean this right-hand side part right here, this second term, should somehow equal the 2 sine squared. So I need to prove that. So I said, okay, well, I need to get rid of the tangent then. So I replaced tangent with the sine over the cosine. So now when we look at this, this is everything being multiplied here. Those cosines can cancel. We have 2 times sine, which, yay, is 2 sine squared on that. So that ends up equaling the other side, and we just verified it. Again, there's other ways to do that. If you wanted me to look at your way, just let me know, and I can kind of look at it and see if you verified it correctly. That's not the only option, but I thought that was one of the easier ones. So if I look at number 4, again, I chose to go on the left-hand side. Again, I saw some operations that I could do. There's some multiplying. So that's why I started on the left-hand side. So I saw it was these two things times each other. So let's go ahead and double distribute. Let's multiply them out. So 1, and then we got minus cotangent plus the tangent, and then minus the tangent times the cotangent. Now, I noticed right here we have a tangent and a cotangent being multiplied. We know that tangent and cotangent, those are reciprocals of each other. So I rewrote it like this, the tangent times 1 over the tangent, because we know when we multiply anything times its reciprocal, we get 1. Now be careful on this. I tend to see people cross them off completely and then like forgetting the 1 right here. Again, when you multiply something times its reciprocal, it's 1. It doesn't just disappear. We get a 1 there. So what that enables us to look at is we have a 1 and a minus 1. Those cancel each other out. So we have a negative cotangent plus a tangent. That really is the other side. I just rewrote it so we could notice that. That's the positive tangent minus the cotangent, and yay, we got our answer there. Okay, I'm going to look at the ones on the back just as a refresher on these. These are our calculator ones. We actually solved these back when we were still actually in the classroom. So I'm just going to go through, again, if you don't need these, you don't need to watch this, but I thought I would go through and remind you how we did these. So our first step on this is getting the sign by itself. So subtract the 6, divide by 10, we get that the sine of x is equal to negative 2/5. So this is where we are allowed to use our calculator because negative 2/5, not a number that we're used to on our unit circle. We use our calculator and we get that x is negative 4.12. However, we need to have all of our answers between 0 and 2 pi, and we need all numbers that are between 0 and 2 pi. So we really have to think about that. So I looked first, oops, sorry, lost it there. I looked first at where is the sign negative. I'm going to draw it a little bit bigger just so I can kind of draw on it here. But if I think about this, we know that our sign is negative, our y coordinate is negative down here in quadrant 4, and down here in quadrant 3 here. Again, doesn't really matter for our purposes. I'm just kind of drawing an idea here. Doesn't really matter where I put that. But right now we have that negative answer, that negative 0.412. Again, negative just means it's going in the clockwise direction here to bring us, right to here. But really what we want to know is we want to know the positive. So if I think about, I want this equivalent angle here, the quadrant 4 angle, but in terms of positive. Couple ways you could do that. You could think about it just being as coterminal, so the negative 0.412 plus 2 pi to find its coterminal. Or I sometimes like to think, instead of even thinking of it in terms of a direction, that negative 0.412, the negative just tells us it goes in that direction, but really that means that that distance right here is 0.412. That means that's our reference angle. Remember, reference angle is the distance to the x-axis there. So I took 2 pi, because 2 pi is all the way around right here. This would be 2 pi, and subtracted that 0.412 to get that angle there. So we're going to think the same thing on this side here. This part right here then is also that 0.412 distance. Again, that's our same reference angle. And if right here is pi, that's why I did pi plus that 0.412 to get our other angle. Again, this angle should be bigger than pi. Pi is 3.14. We are adding that 0.412 to get it to be bigger than that in quadrant 3. All right, number 6, last one, is again kind of similar, except this one has a quadratic. Now, we did some with quadratics where you could factor. We did some with quadratic formula. This one, luckily, we can factor. It's usually a little bit easier when we can factor it. So I factored it, tangent x minus 4 and times the tangent of x plus 4, plus 1 is still equal to 0 there. So we get tangent of x is 4 and tangent of x is negative 1. Now, I tend to see some people look at this one right here and think, oh, that's a no solution because that number is a 4 there. Remember, for the tangent, the range of the tangent function, the range is negative infinity to positive infinity. So the tangent can absolutely equal 4. Again, we don't know what that is on our unit circle. That's why we use our calculator for it. When we did it on our calculator, we get x is 1.326. Here's my little drawing for it here. I'll make it a little bit bigger so we can think about it. So that 1.326, that one is already in our interval that we're looking for from 0 to 2 pi. That's our quadrant 1 angle right here. So that's 1.326. And then we also know that the tangent is positive down here in quadrant 3. So again, that distance right here is 1.326. If this is pi, to find the angle that goes all the way around here, we're taking 1 pi and then we're adding that 1.326 to get to the 4.468 on that one. So now for the second one, we have the tangent of x is negative 1. You can use the calculator on this one. Calculator is allowed, but when I did it on the Casio actually gave me the exact answer, negative pi over 4, which is something that we knew. We know where the tangent is negative 1. First of all, the tangent is negative in quadrants 2 and quadrant 4. So when we think about that, we know it's negative 1 at all those, or positive or negative 1 at all the pi over 4s there. So it's negative 1 at 3 pi over 4 and 7 pi over 4. So I actually even did that then without a calculator. If you thought of it with the calculator, if you wanted to think through the decimal versions of it, I thought it was easier to not do that. But again, right here, that distance as a decimal, that pi over 4 is 0.785 there. So you could do 2 pi minus that to get the 5.498. And then right over here, again, that distance is 0.785. If you do 1 pi minus that 0.785, oh, I'm sorry, that's where we get the 2.356 on it there. So again, I just thought it was easier to think in terms of our pi over 4 since that was an easier one there. Okay, let me know if there's any other questions, and I hope you guys did okay on this. Thanks, bye.